One addendum to this question, I want you to kind of see what the relationship is between the polynomials and the coefficient matrix. Now, notice what happened was whatever the constant was, that's what became the first equation in the system. And so you have all constants here. Likewise, you have all x coefficients here and all x squared coefficients there. But because that means that row 1 is constants, row 2 is x coefficients, and row 3 is x squared coefficients, notice that the columns here end up being the coefficients of the polynomials. Notice if I were to list them as constant x squared, I would have 1, -1, 0, and that's precisely this first column. Here I would have 5, 3, -2, and that's precisely the second column, and 1, 3, -1 is precisely the third column. Now, it doesn't matter how you list them as long as you're consistent. So if you want to do constants first and powers go up, that's fine. If you want to do starting with the highest power and go down, that's also fine. Basically, that would just be a rearrangement of the rows here. And remember that if we rearrange rows on, as far as finding a determinant, it may change the sign, it may not. It depends on the number of rows that you change. But in any case, we got a 0, so whether I change the sign or not, I'm still going to get 0. And in fact, if I had gotten a non-zero number here, meaning this was invertible, then changing rows would just change the sign on that. It would still be non-zero. So I just wanted you to see the relationship between the polynomials themselves and the columns of the matrix. So.